In question number 22, they want us to convert the following complex numbers, which are given in rectangular form, to polar form. In order to do this, recall that a complex number in rectangular form is of the form a plus bi. We want to write it in polar form, which is of the form r times cosine of theta plus I sine theta, where r is the square root of a squared plus b squared. We refer to this as the absolute value or the modulus of the complex number. And the angle theta is such that it satisfies the equation, the tangent of theta equals b over a. For the first complex number, negative 3 plus 3i, we calculate its r value. It's going to be the square root of negative 3 squared plus 3 squared, which will give us a square root of 18, which will reduce to the 3 squares of 2. The tangent of theta is going to be equal to b over a, which is 3 over negative 3, which is negative 1. Thus, theta is going to be the angle whose tangent of theta is equal to negative 1. And if we look at this particular complex number, this would be a complex number that would lie in, quadrant 2. So it's going to be up here. The angle in quadrant 2, whose tangent of theta is equal to negative 1, would be the angle 3 pi over 4. Now that we know r and we know theta, we can put the final answer together. The number z is going to be equal to 3 squares of 2 times the cosine of 3 pi over 4 plus I sine of 3 pi over 4. For the next one, it's 1 minus the square root of 3i. We first calculate the r value for this complex number. Its r should work out to be positive 2. To find its angle, the tangent of theta is going to be equal to b over a. That is the negative square root of 3 over 1, which is the negative square root of 3. The complex number in part B, if we look at it, is going to be an angle that's going to be in quadrant 4. So we need the angle in quadrant 4, whose tangent of theta is equal to negative radical 3. That should be the angle 5 pi over 3. Now that we know r and we know theta, we can put it all together. Z should be equal to 2 times the cosine of 5 pi over 3 plus I sine of 5 pi over 3. And then we have one more in part C. We want to do this again for the complex number z equals negative 5i. If you calculate the r value on this one, r is going to be equal to 5. The tangent of theta would be b over a, which is going to be negative 5 over 0, which is going to be undefined. If we look closer at this complex number, negative 5i would lie on the negative y-axis, which we know is the angle in standard form 3 pi over 2. Thus we have z equals 5 times the cosine of 3 pi over 2 plus I sine of 3 pi over 2.